It's time to learn about inverters. This module will be dedicated directly to the inverters and the different types of inverters out there. So there are two types that we're going to talk about at first, string inverters and microinverters. Now, solar inverters have one core function. It's to convert the direct current, or DC, solar panels generate into alternating current, AC, which is the type of electricity used inside of your home. Now, I want you guys to notice what's happening with the leaf. That's going to cause some shading. We'll talk more about that here in a minute, but keep this picture in mind when we come back. What is a string inverter? A string inverter is also called a central inverter. It's a standalone box that is typically installed close to the main service panel and electricity meter. There's typically only one string inverter or possibly two string inverters on each residential solar installation. It really depends on the overall solar system size. Now, a string inverter functions in a series circuit. There are usually between 6 to 12 individual solar panels in what is called a series string or an array. SMA is the leading manufacturer of string inverters. Now, this is important to know when it comes to series string. It means they're working together. So, there are some pros to having this type of system. They're easy to troubleshoot. The main advantage of a string inverter is that you only need one of them to convert the DC electricity moving from your solar array to AC power. If anything is to fail in the solar system, it's likely going to be the inverter, making troubleshooting relatively easy when things go wrong. Another pro is the cost. Installing single string inverters on a solar panel installation is cheaper than installing microinverters. There's less labor hours required, and string inverters are more affordable than microinverters. And there's a low probability of a wiring mishap. So there's less connections between the solar panels and the string inverter itself. Therefore, there's a reduced chance that a string inverter setup will be improperly cabled compared to a microinverter system. Now, big cons that go along with string inverter systems as well. Compliance with rapid shutdown. Now, if you live in an area that adheres to regulations for rapidly shutting down the system, additional labor and wiring will be required to have this fall into compliance. All territories right now have a rapid shutdown requirement. So a rapid shutdown box will need to be installed near the electrical service entrance, and control wires will need to be routed between the string inverter and the electrical panel. Since there's electricity flowing from your panels and within the string inverter itself, the inverter will be disconnected at both of these two different places. Since the cost of adding the shutdown requirements on your solar system is not negligible, it's important to check with local codes and ask the installer which type of inverter system will work best for you and make most sense for your system and for your install. One of the other cons is going to be efficiency and partial shading. Now, since string inverters run in a series, if one solar panel's output is affected, the entire series is affected in equal measure. So this is a lot like Christmas lights. What happens when one bulb in a Christmas light goes out? The entire string goes out, and you have to play hunt and peck and try to figure out which one it is. Same type of thing happens. So if one gets shaded, the rest of the system gets shaded in equal measure. And I'll show you guys more about this here in a moment. So it's going to be more difficult for system expansion. Here's why. To get optimal performance from a string inverter, it needs to be working near peak capacity. So if you want to increase the system size of the solar array, the panels will need to be routed to a separate string inverter. It's adding additional cost and complexity to the entire system, which is also additional permitting. They do have shorter lifespans, which is typically about 8 to 12 years. Warranties are usually about the same as that, and microinverters typically have about a 25-year warranty on them. One of the biggest things that folks don't like about string inverter systems is that system monitoring. You can see the overall aggregated production, but you can't see what each individual panel is doing. So because they run in series, you get to see everything that your system's producing. But if one of the panels isn't working, if there's a defect from crack, debris, anything that's going on with the panel itself, you won't see what panel is going bad or which isn't functioning properly for whatever the case may be. You only get to see that the entire system now dropped production. And you're going to drop more production because they run in a series. If one goes down or one loses production, the entire array now drops the same efficiency as the rest of the system. So let's go back and talk about this. So remember that image that I had you guys put in your head earlier about that leaf on the panel. Because if one panel gets shaded, this entire array is now going to reduce efficiency. So it could be as much as 50% in some cases, right? The standard is about 30 to 40% efficiency drop because one panel got shaded on the entire array. So what happens if one panel stops working? Again, let's talk about those Christmas lights. Because if one bulb goes out, the entire thing does. So the same thing happens with the array. So you'll see the entire system drop its production. If you have two arrays, you just saw an entire array outage, the system stopped producing by about 50%. You don't know why. Was it shading or was it because the panel's no longer working?